What up? It's Wharton back again. 5.2 natural log integration. What? We're going to integration already? Yup. Alright, so log rule for integration. We got a couple things going on here. When I integrate 1 over x dx, I'm going to get the natural log, but because I don't actually know what the value of x is, I have to make it so that it's the natural log of the absolute value of x plus some c, right? There's no upper and lower bounds here, so we have to have some c. Okay, in this case, it's the same thing, right? So it's the natural log of the absolute value of u plus some c. We got to worry about that absolute value only when I know that the value is going, it could be negative. Like if it's like x squared or something like that, or I figure something out, okay? Or if the value can never be negative, if you think about it, then that absolute value can go away. But until then, you need the absolute value, okay? All right, this one here. So this can be rewritten as 2 times that integral of 1 over x dx. So if I integrate that, that's 2 times the natural log of the absolute value of x plus some c there. Alrighty. In this case here, we don't really know what's going on. But what I can do is I can't really split the fraction, right? Because it's a binomial underneath. So I'm going to say, okay, u is equal to 4x minus 1. du is equal to 4 dx, and therefore dx is equal to du over 4. So this 4 has got to get pulled out, right? So don't forget about that pulling out of that 4. So this can be rewritten as 1/4 times the integral of 1 over u du. And therefore I get 1/4 times the natural log of the absolute value of u plus some c. Okay, plus some c, which equals 1/4 of the natural log of the absolute value of 4x minus 1 plus some c. Okay, I got to plug that u back in, right? All right, I think we got 2 more, and we're going to call it a day. This is a pretty fast video. All right. This one here, what I'm going to have to do is I'm going to say, okay, u is going to be my x plus 1. Okay, and du is equal to just dx. Right, so I'm good there. And so then I'm going to say this is equal to 2x over u squared du. But I got this x here. So I got to solve for that x. So x is equal to u minus 1, right? Because I can bring this over and solve for x equals u minus 1. And so my integral from 2 times x is u minus 1 over u squared du, that's equal to the integral of 2u minus 2 over u squared du. But that's equal to the integral of 2u over u squared du minus the integral of 2 over u squared du. I can split that integral because I have a monomial in my denominator with a binomial up top, and I can split that integral. And so this is the integral, or this is equal to 2 times the integral, I skipped a step there, 1 over u du, minus 2 times the integral of u to the negative 2 du. And the 1 over u we know is the ln, right? So it's 2 times the ln of the absolute value of u, okay, plus some c, but that doesn't really matter too much right now, minus this u to the negative 2 here. Remember, I got to add 1 and divide by that same value, right? So I'm going to add 1, which is a 1, negative 1, and I'm going to divide by that negative 1, which makes it a positive 2, and so it's u to the negative 1. Then plus some c, all right? Which then, okay, I got to fill in for that u value, so I get 2 times the ln of the absolute value of x plus 1 plus 2 times u to the negative 1, which is x plus 1 to the negative 1, which is x plus 1 in your denominator, plus some value of c. Okay, there's your integration right there, right there. This one, now I'm going to actually have bounds. All right, so because I have a whole bunch of stuff there, x, ln of x, you're going to integrate, but when you integrate and you find your u value, your u substitution, I'm not going to make u x because that doesn't really help with my ln. So I'm going to make u my ln of x, and therefore du is equal to 1 over x dx. Okay, and that's easy because the 1 over x, right, is going to cancel when I change this around. Okay, so this x and this x are going to cancel. So this is the same as the integral of 1 over u du. But because I changed my integral, I'm going to change my bounds. The 2, if I plug it in here, this is now the ln of 2. And if I plug e in there, I get 1, right? The ln of e is 1. And if I integrate this, I get 1 over... I'm sorry. Nope. Hold on. Let me back it up. Back that truck up. Okay. I get the ln of the absolute value of u from the ln of 2 to 1, right? I don't need the c there if I'm actually evaluating it. And so then I get the ln of 1 minus the ln of 2. The ln of 1 is 0. Okay, the ln of 1 is 0. And minus the ln of 2. And so that's my answer right there, just negative ln of 2. Alright, that's it for this video. Hopefully that's not much longer than, like, I don't know, 15 minutes. Hopefully not. Alright, deuces.